Good morning, everyone. I'm going to send out a remind to make sure everyone knows to come to YouTube Live. Hope everyone had a nice weekend. Does anyone have ash on their car this morning? My car has a lot of ash on it. So I think my threshold to start is going to be 30 people. Thanks for the like, whoever gave me the like. We are waiting for more people to join the live stream. Check out this mug. I've got a brown Boston Terrier and a black and white Boston Terrier, so this is the perfect mug for me. It's so cute. Oh, we're up to 28. 2 more and I'm going to start. We're at 30. Awesome. There's 36 people in this class, but you know, I can't wait forever. We got a lot of physics to learn. So good morning, everyone. I hope you had a nice afternoon, or a nice weekend, excuse me. It was super hot. So I hope you guys were able to stay cool. So today, we are going to be continuing to learn about velocity. So go ahead and get your notes out. And just a reminder to submit your attendance form. Get in the habit of submitting that attendance form. And also a reminder that after this lesson is finished, we will be meeting in the Zoom room. One thing I did get a couple of messages about on Friday was that it takes a while so after my live stream, it takes a couple of hours to show up on my YouTube channel as a permanent video. So if you're looking for that live stream immediately after I live streamed, it's not going to be there yet. It takes a couple of hours. So just keep that in mind if you happen to miss a lesson. All right, so let's just do a super quick review of what we learned on Friday. We learned about displacement, delta x, which is final position minus initial position. We learned about distance traveled. Okay, which doesn't. I don't know, we could call it S, maybe. Typically it's called S. And the distance traveled is like what an odometer would read. So, if you go forward 5 meters and you go back 5 meters, your displacement is 0 because you ended up in the same spot that you started at. However, your distance traveled would be 10 meters, okay? So that's the difference between displacement and distance traveled. We also learned the equation for velocity, which is displacement over time. And remember, velocity is basically speed with direction. Okay? Oh, and I wanted to remind you guys to please, if you have any questions, type them into the live chat, and I will be happy to answer them. So, to sort of explain today's lesson, we're just going to have an example. This example is inspired by my morning because I was very groggy this morning. And so I woke up and I kind of didn't know what I was doing, and I just kind of wandered around for a little bit. Maybe you guys do the same thing. So I'm going to draw my path just as a number line. And I started at position 0 at the origin. And then I walked forward to position 7 meters. And that journey took 3 seconds. And then after I walked forward 7 meters, I kind of forgot what I was doing, and I just stayed put. I just stood there for 4 seconds, just kind of processing what the heck I was doing. Okay. And then I realized that I actually wanted something on the other side of the room. So after I waited for 4 seconds, I then walked all the way over here to x equals -3, and that journey took 2 seconds. Okay? So yeah. So this is the example that we're going to be working with first. So it's just kind of me. I woke up in the morning, I walked forward, I spaced out for a couple seconds, I walked back. All right? And so one of the concepts I want to teach you guys about is something called the instantaneous velocity. Okay? There's also correspondingly an instantaneous speed, and that's your velocity at a particular moment. Okay, so we can see that this example is made up out of 3 pieces, and I have a different velocity in each of those pieces. Okay, so what if I said what is my instantaneous velocity? Instantaneous velocity, let's say 2 seconds into the journey. What is the instantaneous velocity 2 seconds into the journey? Well, 2 seconds into the journey would be during this first segment, right? Because that first segment lasts for 3 seconds. Okay? So how far did I go in that in those first 3 seconds? Well, I went 7 meters, okay? And then that first segment took 3 seconds. So my instantaneous velocity in the first segment of the journey is going to be 2.3 meters per second. And I'll put a plus there because it's a velocity to indicate direction, okay? So I would say that my instantaneous speed in that first segment was also 2.3 meters per second. All right. Then we could say, what was the instantaneous velocity at, let's say, 4 seconds into the journey? 4 seconds. So 4 seconds into the journey, well, I spent the first 3 seconds going from 0 to 7 meters. And then I spent the next 4 seconds doing nothing, okay? So from 3 seconds to 7 seconds into my journey, I was just chilling out, just sitting in one position. So maybe someone can type in what was my instantaneous speed 4 seconds into the journey. Okay? And the next part is, of course, to find the instantaneous velocity, let's say maybe 8 seconds into the journey. So we're going to do that next. But I'm just setting that up for later. First thing I want to know is, what is the instantaneous velocity 4 seconds into the journey? If someone could type it into the live chat so I can see if you understood. Super easy question, but I think people are shy this morning. Oh, there we go. We got an answer. 0, that is correct. Excellent. So because during the second segment of the journey, the person is at rest, there is no velocity. So at 4 seconds, the instantaneous velocity is 0 meters per second. Very good. Very good. Okay, so now if we look at 8 seconds, 8 seconds into the journey would be during the third part, the third arc. Why is that? It's because the first two parts of the journey took a total of 7 seconds. Okay, so anything after 7 seconds is going to be the third part. So in the third part, I go from 7 to -3. So that is a displacement of -10 meters. Okay? And the time elapsed for that second part, or for the third part, excuse me, is 2 seconds. So I traveled 10 meters to the left in 2 seconds. So that is an instantaneous velocity of -5 meters per second. And I'm putting that sign in there to indicate the direction of the velocity. All right? So that's how that works. So yeah, that you could think about your instantaneous speed. If you're in a car and you're driving around, your instantaneous speed is what the speedometer is reading at a given instant. Okay, the speedometer is always changing because moment to moment your speed is changing, and if you're turning and you're changing speed, your instantaneous velocity is changing. Okay, so that's our first concept for today. Is the concept of instantaneous velocity, which is your velocity at a particular moment. Okay. The second thing we're going to talk about today is something called your average velocity. Okay. So let me give you an example of average velocity. My family lives in Washington State, and I oftentimes will drive from California to Washington State to visit them. Okay, and because I don't like to waste time, I typically will drive it in one day, and it takes about 18 hours. So it's a lot of time in the car. Um, so I travel, and the distance is about 1,100 miles. So I go 1,100 miles in 18 hours north. That is my average velocity because that was the entire journey. Took me 18 hours. It was 1,100 miles. So that average velocity, if I do 1,100 divided by 18, that means my average velocity was 61 miles per hour north. Okay? However, was I going 61 miles per hour north the entire time? No, I was not. Okay? Actually, when I was on the freeway, I was probably going more like 85 miles per hour north. Okay? Maybe even faster if I thought I could get away with it. But, of course, I might get stuck behind a truck and my instantaneous velocity goes down to 50 miles per hour north. I might stop to go to the bathroom or get food or something like that. So average velocity is looking at the entire trip as a whole, okay? So your average velocity is your total displacement divided by the total time elapsed, okay? Total displacement divided by total time. So what was my total displacement for this journey this morning? Well, I started out here at 0, and I ended up at -3. So my total displacement was actually -3 meters. That because remember, displacement doesn't care about the details. It cares about where did you start and where did you end up. So I started at 0 and I ended at -3. So that's a displacement of -3 meters. Okay. And then what was the total time elapsed for this journey? Well, I spent 3 seconds on the first segment, and then 4 seconds on the second part, and then 2 seconds on the third part. So the total amount of time elapsed was 9 seconds. So that means that my average velocity was -0.3 meters per second. So I'm obviously rounding, it's -0.33333, but I'm just rounding it to -0.3. Okay? So this is actually pretty close to 0. Why is it so close to 0? It's because I wasted time going in the opposite direction from where I ended up going. And I even wasted time just sitting still. Okay? So that concept is called the average velocity. Okay? And there's another quantity which is called the average speed. So speed has to do not with displacement, but with distance traveled. And so my average speed would be the total distance traveled over the total time. Okay? Total distance traveled divided by total time. So I would like you to type into the live chat, if you know the answer, what is the total distance traveled for this journey right here? Okay? What is the total distance traveled? And then the denominator is very simple. The journey was still 9 seconds. Okay? So that's going to be 9 seconds. And some people have typed in very good that that the total distance traveled is 17. Excellent. Why is that? It's because you traveled forward 7 meters, and you traveled 0 meters for the second part, and then you traveled back 10 meters. So that would be a total distance traveled of 17 meters. So 17 meters in 9 seconds. 17 over 9, 1.9 meters per second or so. And when we're quoting a speed, typically speaking, when we're quoting a speed, we don't put the plus or the minus there because it doesn't have a direction. Okay? So if we're talking about a velocity, we explicitly put the plus or the minus in. But if it's a speed, we do not. Okay? So we're going to go to the do a second example just to make sure that everyone's understanding this, and this one's going to be slightly different. Okay? We're going to say that a car travels at, let's say, 40 miles per hour for 3 hours. 40 miles per hour east, let's say, for 3 hours. And then the car travels at, let's say, 60 miles per hour east for 5 hours. Okay, so we have two parts to this journey. All right. So let's analyze this motion. What is the instantaneous velocity 1 hour into the journey? Okay, 1 hour in. Now keep in mind that this problem is giving different information. In the previous problem, we were given displacements and times. Okay. In this problem, we're given velocities and times. Okay. So this is actually the instantaneous velocity for the first part of the journey, and this is the instantaneous velocity for the second part of the journey. Okay? So actually, the instantaneous velocity 1 hour into the journey is just the velocity for this first segment, which is 40 miles per hour east. Okay? 40 miles per hour east. What would be the instantaneous velocity 4 hours into the journey? So I will wait for someone to type it into the live chat. Okay, and while I wait for someone to type it into the live chat, I want to know what is the average velocity for the entire journey. Okay. So the average velocity is going to be the total displacement divided by the total time. And I can see someone has typed in 60 miles per hour east. Technically speaking, you want to have that east on there as well. Very good. So for average velocity, we have to be a little bit careful, okay? Because some of you, I'm sure, are thinking in your head, well, the average velocity is going to be 40 plus 60 over 2. So that would be 50, right? However, it's not going to be 50. Why is that? It's because we were going 60 miles per hour for a longer amount of time than we were going 40 miles per hour. Okay, So that skews the average towards 60 miles per hour. So it's not going to be halfway in between. It's going to be closer to 60 miles per hour than it is to 40 miles per hour, okay? Just like if I were to, you know, I like to run marathons, so, you know, occasionally if you're running a marathon, you have to go to the bathroom, okay? And you run your marathon, and you might stop for 30 seconds to go to the bathroom, or a minute, or however long it takes. And so that reduces your average velocity a little bit, but not very much, because that's a very brief moment that you were stopped, okay? So how are we going to get the total displacement? Well, let's figure out the displacement in each segment of the journey. For this first segment, I'm going to use velocity is displacement over time, okay? And I know that the velocity is 40 miles per hour, and the time elapsed is 3 hours. So we can solve that equation quite easily just by multiplying both sides by 3, and we get 120 miles is the displacement for that first part, okay? Plus 120 miles because we went east. Okay, for the second one, for the second part of the journey, I think it's fair. We can do an analogous calculation, and we get that the total displacement would be 300 miles. Okay, so these two displacements are going in the same direction, so I don't subtract them, I add them together. So the total displacement is 420 miles in the positive direction, east. And the time for the journey was 8 hours. Okay. The time elapsed for that journey is 8 hours. So I do 420 divided by 8 is 52.5 miles per hour. So plus 52.5 miles per hour is the average velocity. So notice how I said it was going to be closer to 60 than it was to 40 because you spend more time traveling at 60 miles per hour. So you got to be careful. When I say average velocity, it doesn't mean just take them and take the sum and then divide by 2, okay? Because it factors in how much time you spent going at each velocity. If I wanted to know the average speed, that would be total distance traveled divided by total time. Okay? Who can tell me in the live chat why the answer is going to be exactly the same as total, as average velocity? So the answer is going to be 52.5 miles per hour. And type it into the live chat if you know why. And while I'm waiting for you guys to type that in, I'm just going to say that when I'm quoting an average speed, I don't need to put the plus or the minus. Okay, very good. I can see some people are typing in that really the difference between velocity and speed is most important when you're switching directions. And because this is all going in the eastward direction, I don't have to really differentiate between the two. Okay, very good. All right, so that's how that works. Okay, so now we're going to move on to our final concept for today, which is the concept of acceleration. Okay. Acceleration is denoted by A. All right. And acceleration is equal to the rate of change of velocity. Okay? Your velocity can change. All right? You go in a car, you hit the gas pedal, your velocity changes. You hit the brakes, your velocity changes. You turn, your velocity changes. All these things change the velocity. So the velocity is not a static, constant thing. It's dynamic. It changes. Okay. And the acceleration is the measure of that. Now, when I took physics in high school, my teacher had a really great explanation, I thought, for what acceleration is. My physics teacher said that acceleration is how fast you get fast. It's how fast you get fast. Okay? So I really liked that. But there are other ways you could say that, right? Because also change in velocity could mean turning. So I'm going to also add to that, or how fast you change direction. Okay? Or you could think about it as how fast you slow down. Okay? So all these things are accelerations. The actual definition of acceleration is change in velocity over change in time. All right, so this is our definition of acceleration. Okay. Very good. So that's rate of change of velocity. So what I would like to do now is whenever I define a new quantity is we want to talk about what are the units of that quantity. So when we say units of, that means we put square brackets around it. So this means units of acceleration. And we can see that an acceleration is a change in velocity divided by a time. A velocity divided by a time. Velocity is measured in meters per second. Time is measured in seconds. So velocity divided by time would be meters per second, which is also known as the meter per second squared. So we're going to measure acceleration in meters per second squared. Okay? All right, so let's do some examples with acceleration, and then we'll transition over to the Zoom room. One of the most common places where you're probably familiar with acceleration is 0 to 60 time. Okay, you ever hear someone talking about a car and they say this car can go 0 to 60 in 5 seconds or something like that? Okay. That's a measure of acceleration. They're saying, what is the acceleration of the car? All right. So let's say BMW goes 0 to 60 miles per hour in 4.3 seconds. What was the acceleration? So first thing I want to do is I want to put the 60 miles per hour into meters per second. So I'm going to do a quick. In my class, we could spend a lot of time focusing on unit conversions, but I personally hate doing unit conversions. So I recommend that you just type it into Google. You should know how to do it, but I don't think it's worth. You guys were supposed to have learned that already, and so I don't really spend a lot of time dwelling on unit conversion. So I'm going to type in 60 miles per hour to meters per second in Google, and it is 26.8 meters per second. 26.8 meters per second. Okay? So my acceleration is my change in velocity. So that's v final minus v initial over the time elapsed. So my final velocity was 60 miles per hour, or 26.8 meters per second. My initial velocity was 0, because it's the 0 to 60, okay? All right. And then the time elapsed was 4.3 seconds. So doing that calculation, 26.8 divided by 4.3, 6.2 meters per second squared. That is the acceleration. I'm going to put a star next to that because that's a key concept for today. All right. I would like to do one more example before we switch to the Zoom room. We're not going to do the example all the way through, but let's say that a spaceship traveling at 100 meters per second reverses its velocity in 4 seconds. What was its acceleration? So what does that mean to reverse your velocity? So if your velocity is plus 100 meters per second, reversing your velocity means you are now going the same speed but in the opposite direction. Okay? So the final velocity here is negative 100 meters per second. The initial velocity is plus 100 meters per second. So I have minus the quantity plus 100. You got to be careful with negative signs and double negatives and things like that in physics. And then that took 4 seconds. Okay, so that means an acceleration of minus 200 over 4. So that would be minus 50 meters per second squared. All right. So that's my lesson for today. So we are going to switch over to the Zoom room at this time. Thank you for watching.